Welcome viewers, in this video we will see the details about inverse transmission parameters A dash, B dash, C dash and D dash, that is coming under two-port network. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Under two-port network, inverse transmission parameters. The transmission parameters A, B, C, D is a separate video available. This is inverse transmission parameter. So first we will see in transmission parameter what is the parameter we are having. In this, the input port voltage and currents are expressed in terms of output port voltage and current to describe the transmission parameter. So in normal transmission parameter, input port voltage and current is expressed in terms of output port voltage and current. While defining the transmission parameters, it is customary to designate the input port as the sending end and the output port as the receiving end. So these two paragraphs refer transmission parameters, normal transmission parameters. That is what is given here. The sending end, input port is referred as sending end, output port is referred as receiving end. So we'll go into inverse transmission parameter. What happened? Just opposite of this. We'll see that the voltage and current at the receiving end can also be expressed in terms of sending end voltage and current. So the receiving end, output port current and voltage is expressed in terms of input port current and voltage, just opposite of transmission line parameters. V2 and I2 is expressed in terms of I1 and V1. Now we'll see the equation. So if the voltage and current at the port 2 dash, that means output port, are expressed in terms of voltage and current at the input port 1 dash, right? So in inverse transmission parameter, what we are doing, output port current and voltage is expressed in terms of input port current and voltage. So that is given here. Now we'll refer the port. So this is the port, two-port network. This input port 1 dash, 2 dash output port. V1, I1 is current, voltage and current at the input port. V2, I2 is the current and voltage and current at the output port. So here V2, I2 is expressed in terms of V1 and I1. So V2 equal to A dash V1 minus B dash I1. This negative refers the current is flowing in reverse direction. I2 equal to C dash V1 minus D dash I1. So this is the general equation for a inverse transmission parameter. This A dash, B dash, C dash and D dash is the inverse transmission parameter property similar to the transmission parameters. A, B, C, D is transmission parameter. A dash, B dash, C dash, D dash inverse transmission parameter, just opposite of the transmission parameter. In transmission parameter, V1, I1 expressed in terms of V2, I2. Here V2, I2 is expressed in terms of V1, I1. Now we'll see how to find the value of this A1, C1, A dash, C dash, B dash and D dash. We need to find the value of these four parameters. So the first case, when the port 1 is open circuited, we kept the port, input port is open circuited so that I1 equal to 0. Input port is open circuited, I1 equal to 0. So while referring this equation, I1 is 0. So this term is 0. Here also this term is 0. While making input port 1 dash is open, I1 is 0. So these two terms are got cancelled. So only one term is available. V2 equal to A dash V1. B dash I1 is 0. I1 is 0. So entire term is 0. So that A dash equal to V2 divided by V1. A dash equal to V2 divided by V1 with I1 equal to 0. Similarly here I1 is 0. So this entire term is 0. I2 equal to C dash V1. C dash is nothing but I2 divided by V1. Brought this V1 in the denominator. So C dash equal to I2 divided by V1 with I1 equal to 0. So A dash C dash parameter is calculated, is expressed. The equation for A dash C dash is calculated by making 1 dash is open, I1 is 0 by referring the equation. Now we'll see how to find the B dash and D dash. For that, what we are doing, if the port 1 dash it's short circuited. In previous case, the port 1 dash is open circuited, now short circuited. So current will flow, voltage is 0, V1 equal to 0, right? There I1 equal to 0. So V1 equal to 0 means this term becomes 0. Similarly, this term becomes 0. So V2 equal to minus B dash I1. So B dash equal to or minus B dash equal to V2 divided by I1. Otherwise, B dash equal to minus V2 divided by I1. Brought this I1 in the denominator. Similarly, this term is 0. V1 is 0. So I2 equal to minus D dash I1. So minus D dash equal to I2 divided by I1. Right now, we'll see this equation. What we referred, it is available. B dash equal to minus V2 by I1 by making V1 equal to 0. Similarly, D dash equal to minus I2 by I1 by making V1 equal to 0. So, by short circuiting the input port, we calculated the remaining two parameters B dash and D dash, that is making V1 equal to 0. So, we calculated all four parameters. By making input port open circuited, we calculated A dash and C dash. By making input port short circuited, we calculated B dash and D dash. So in this video, we discuss what is meant by inverse transmission parameter. Transmission parameter video available separately. So in the transmission parameter, input current and voltage is expressed in terms of output current and voltage. Here it is completely reverse. Output port current and voltage is expressed in terms of input port current and voltage. Finally, we got the expression for all four inverse transmission parameters A dash, B dash, C dash and D dash. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. All the best for your examination. You can refer the other videos. All the videos related to two-port network is available. Hybrid open circuit impedance parameter, short circuit admittance parameters, ABCD parameters, inverse ABCD parameter, all videos are available. The link is given in the description box. Thank you for listening.